I started the recording. So basically today I was about to show you, some basics about Google Cloud, and we could start with the Linux basics. But before that, what I want to let you know is about like the very basic of Hadoop. So yesterday we had discussed about like what was big data, basically what was the problem, how it got evolved, and what were the solutions. Those are providing some solutions to big data issues. Actually, just be on mute. And we have seen that how Hadoop, being an open source solution to big data problem, how it solves using the scalability in a horizontal way, basically, and any solution that would be a horizontal scale that can horizontally scale is said to be scalable solution. Okay, so most of the times when you actually hear any interview or any other for about any component or about any services, basically you will mostly hear the word called scalable, and that scalable means always horizontally scalable. It means that you just need to add the more number of machines, more hardware to it, and you will extend your you will extend the data capability, data handling capability of that particular thing. So we need to first understand, like so yes, and we also hear about like HDFS, that is called Hadoop Distributed File System, and MapReduce. So we have just named it few times, and we have seen that how you can connect multiple laptops in order to increase the data handling capability with some fault tolerance added. Okay, so when I say Hadoop Distributed File System is a fault tolerant file system, it means that the data loss, the complete loss of data would be, we can prevent it just by adding more and more copies of the data. Okay, so just like if you are having 1 terabyte of data, basically you can replicate it on a different machine, so that even if one machine has gone down, basically the other machines will still be able to provide the data access or provide the information about the data. So that is how actually using the replication factor, using the replication policy, basically Hadoop Distributed File System will provide you the fault tolerance. Okay, so any scalable solution should be always, whenever you see anything in the Hadoop world or big data stack, basically it should be first of all scalable, and second thing, it should be fault tolerant. Okay, so what I will show today is the basic architecture of Hadoop, so that you can understand what how it achieves those things. Okay, so again today would be a kind of session wherein you will get the idea about like how Hadoop is architectured, basically, and then everything, when this is the basic architecture that we are going to see today, and everything will turn around this basic architecture about. So now being an administrator, basically you will find a lot of components that will either interact with these components, and then through different components you will try to manage the things of basic architecture of Hadoop for this basic component. And then some components would be like work on the abstraction level, that is like underline HDFS or over MapReduce, and you just need to know basically try to understand the connection, so that you will be more able to solve any issues related with the configuration, related to the working of it, related to extend the capabilities of these components, and then adding more nodes and just increase the overall capability of your Hadoop cluster. Okay, so before starting this, what I will try to explain is the basic file system. Whenever we talk about any operating system, basically, or so Hadoop also is not, basically it's not an operating system, but it runs on OS, that is what is called Linux, right? So Linux is basically the operating system, and on the top of which basically most of the production Hadoop installations will be done. Okay, though the Hadoop installation can also be done on Windows, Hadoop installation can also be done anywhere where the Java runtime environment is supported. Okay, so I will tell you more on the differences about or among the JDK, JRE, and JVM, that is what is called Java Virtual Machine. These three terms are very important, though there are very minute differences among them, but most of the times you will hear these words, and you need to know like what are they basically. So I will cover all this today, and try to create an imagination, basically some some kind of architecture in your mind, so that you can start thinking on the level where you can now feel the feel the capabilities or feel the responsibilities of being an administrator, how you can help in this architecture overall. Okay, so we will start with the basic file system understanding of Windows. Okay, so no matter like which operating system you are working on, either it would be AS400 or OS 400 or Linux or Windows or Solaris or Mac OS or Android or iOS, whatever. I mean, there are multiple choices of operating system that you can use for different use cases, right? So Windows being very user friendly, it's being like our so you need to know very little about operating system just to work with Windows. But I mean, you talk about Linux, and basically you will be working most of the times in command line. Basically, you need to know further more details. Just like when you talk about OS 400, most of the things you will handle through commands basis, right? So when you talk about command, you should be knowing what command and what are all the commands those are there to use with, so that you can do the things better. So every operating system, any system, requires a file system under the hood. Okay, because that is where you will place all the configuration that is required by the operating system to either whatever you installation you will do, ultimately it is going to be stored on your hard disk, right? Without hard disk, you cannot the operating system cannot survive itself. So file system is something that is actually that is existing on the hard drive or hard disk, basically, on the top of which you will install your OS 400, operating system, and then everything that you are going to install, either it is a software or any other utility or any tools, basically it is all going to occupy the space in your hard disk. So the base of everything, or the base of every operating system on the top of which it is built, is always a file system. Okay, now there are variety of file systems. So the basic understanding of any file system is very is very mandatory. So what I will do is I will try to just tell you that how the basic file system on my current laptop, that is on Windows over here, it is working. Okay, and we need to understand the concepts behind it, just like the size of what is the block actually, how the file is getting stored in the file system and how it is getting retrieved while we read it. Okay, all the stored file, if we want to read it, then how the reconstruction of that file is done. So everything in bits and pieces. Okay, and once you understand this particular basic file system concept, basically the same will be applicable to any other file system on this earth. Okay, even a Hadoop distributed file system, since it is file system, though it is not a real file system, I will let you know later that why I'm saying that it's not real. But anyways, it is a file system. We can consider it as a file system, so it will also work on the similar concepts. Okay, so what I will do now, I will create a notepad file over here, and I will say text document, and I will just say sample. And what I will do is I will open it, and I will write one letter in it, that is A, and I'm saving it, Control S, and I am just closing it. Okay, now this is our file. Now everyone of us knows that basically it is stored somewhere in our hard drive, right? So if you really want to check where it is, so just go in on the properties, and you will get to know that it is basically stored somewhere in C drive, and under user, this is my user ID, and then under the desktop, because this is the path of desktop where actually it is stored. Okay, now very important thing is when you talk about the size and size on disk, these are two parameters which you will be knowing about. You will see that there is only 1 bytes, that actual size. Okay, so when I say size and there is nothing in front of it, so basically it would be an actual size, and this is the size on disk. Okay, so these are two terms, or these are two things that we need to understand, and what are the differences among these two, basically. So we just need to understand that. When you open this particular sample.txt, you see that there is only one character A, and that's why actually it has shown you that it has occupied only 1 byte on the system. Okay, or it is having stored only 1 byte of data in it. That's what actually it is trying to tell. 1 byte means 8-bit. Okay, and since it is like kind of ASCII character, and it's like 256 kind of characters that can be accommodated within that ASCII, you can say the scheme of providing all the things. So A will or any character, any single character will occupy one complete byte in your hard disk. But if you try to see here, the size on disk is 4 kilobyte, that is 4096 bytes. Okay, now this is what here we are actually storing only 1 byte, but it is telling that on the disk, on the disk size on disk, basically it is 4096 bytes. Okay, so let me just connect to my phone. Okay, so what I will do, I will just show you that how what is the meaning of that two thing. Okay, so whenever we talk about any file system, let's say I am having this is the hard disk space that I am having under the operating system. Okay, and whenever see, the thing is, whenever we start installing the things on any of the laptop or any machine, basically we need to first format the hard disk. Okay, and that formation, or whenever we do the formatting of that hard disk, basically it is to be said that we are actually installing, or we are actually giving the file system scheme that we are going to use for that particular storage. Okay, so there are numerous file systems available. So if you talk on Windows world, basically it would be FAT32, it is the name of the file system. Then we do have NTFS, it is the name of the file system. On the Linux world, basically you will find the file system like ext3, ext4. Okay, so these are like Linux operating system file system, and this is Windows. I will just write Win. Okay, now if you are going to install Windows operating system on any of the laptop, basically you need to first whatever hardware you are preparing, you need to first the first thing that you need to do is basically you need to format your hard disk in any of these available file system, either FAT32 or NTFS. Okay, now file system is having one basic, or the smallest unit of data that it will handle. Okay, it cannot handle any size of data. There should be one smallest unit that you need to define for any of these available file system, that how much the smallest set of data or smallest unit of data that it will handle. Okay, so that smallest unit of data or smallest unit of data size, smallest unit of data that any file system will handle is called block. Handle is called block, BLOCK. Okay, now the block size of FAT32 is 4 kilobyte, and the block size of NTFS is 3 kilobyte. Okay, I may be wrong in that sense that it would be reverse. Basically, I did not. I mean, I just need to Google what is, but mostly 99% it is like FAT32 is basically 4 kilobyte and NTFS is basically 3 kilobyte. Okay, now whenever you format your hard disk either with FAT32 and NTFS, so let's say take an example that we are now formatting our hard disk with FAT32 file system. What it will do is, like, this would be this big blue rectangular is, let's say, your hard disk space. So what FAT32 formatting will do is it will create more like blocks, multiple smallest like it will create all the blocks in that. Each block would be represented, or each block is of the capacity of 4 kilobyte. Okay, and your whole hard disk will be like divided, or you can say it will be divided into the numerous blocks. Basically, suppose if you are having 1 terabyte hard disk, so you just say 1 terabyte divided by 4 kilobyte, so that many number of blocks will be created in your file system. Okay, so if it would be, let's say 500 GB, so it would be like 500 into 1024 MB, and then finally kilobyte, and then divided by 4 kilobyte. So depending on that many number of blocks will be created. So sometimes, I mean, for 500 or 1 terabyte, it would be millions of blocks that will be created under in your hard disk while you're actually trying to format with FAT32 or NTFS. Okay, each of this block is of the capacity of 4 kilobyte. Each of this block is of the capacity of 4 kilobyte. And when you talk about the FAT32, and so this is first thing, that any file system will handle the data in its smallest unit, and that smallest unit is called block. Okay, so ultimately you are not when you are actually doing formatting, you are just creating the numerous blocks, each of which is of 4 kilobyte. Second thing, that each of these blocks are associated with one unique identifier. Okay, just like the number plate of any vehicle. So we have, like, kind of crores of vehicles in India, or abroad basically, but every of that vehicle can be easily identified, that it would be a chassis number or it would be a vehicle number. Am I audible now? Hello? Am I audible now? Yeah, it was a glitch in my network, so I will repeat. Okay, so basically, what I was trying to say is that the first thing is that every file system is having the smallest unit of data that it is handling, and that is what is called block size. Okay, now this block, when we format the hard disk using any of the available file systems, either FAT32 or NTFS, it is going to create those numerous blocks basically in your file, in your hard disk, and each of which is basically of 4 kilobyte. Okay, now that would be the smallest chunk of data that the file system will handle. Second thing, what it will do is basically it will associate a unique identifier with each block, so that each block can be identified uniquely. Okay, it means that the size of this particular first block would be 4 kilobyte, and let's say I will say it would be a block 1, BLK1. So this BLK1 is like kind of an associated identifier with this particular block. So for the next block, it would be BLK2, then third block BLK3, and then so on. So it would be a running number, you can say. So most probably, most frequently, it would be a kind of hexadecimal number. Okay, that will be associated with each block, and that would just provide the uniqueness just to identify the block within the hard disk. Okay, it is just like kind of independent houses within your hard disk, and each house can be have given an address so that it can be independently identified. Okay, so it would be just like kind of just provide the uniqueness, because if you are having, let's say, we do have like a unique number for every vehicle, a unique number of chassis for every vehicle, just to identify that particular vehicle uniquely in the group. So here also, no matter if there are like millions of blocks in this hard disk, and every block will have associated a unique identifier. It means that identifier is completely associated with that block only. That identifier cannot be given to any other block in the file system. Okay, so these are two very basic things that any block will have with it. One, its size, that it would be 4 kilobyte if it is FAT32. It would be 3 kilobyte if it would be NTFS. And then similarly, this ext3 is 3 kilobyte and ext4 is 4 kilobyte in Linux. So no matter either you are using Windows or Linux, basically ultimately the basic file system design or basic file system concepts will be similar to both. Now this 4 kilobyte will be used in order to now store the data. Now each of these block is going to be stored, is going to be used to store the data, that whatever you are going to put. Now, if I come back to the file that we have created, that is a sample.txt, if I again go to the properties of it, it will tell that it is having only 1 byte, but actually it is occupying one 4 kilobyte block, 4096 byte completely on size of it. It means that whatever a that the sample.txt that we have created, sample.txt, and within that we have only a character, that is actually stored in this first block. Okay, I'm just presenting it. I mean, we don't know that which particular block in the hard disk it will going to be occupied, or it will going to be stored in. But let's say, just assume that the sample.txt is actually whatever data in that is actually stored in the first block. Okay, now the problem is that if you store only 1 byte, okay, and This sample dot text is now actually stored on, let's say, block 1, that is the unique identifier associated with that block. uh, the remaining space in that block, that is, since it is a 4 kilobyte, so there is 4095 bytes are still available in that in that particular 4 kilobytes of blocks, right? So that in that blk1, that is in the block 1, where we have stored the sample.txt, 4095 bytes are still remaining. So can we use that further in order to store the new data? No, we cannot. Okay, so that is the concept of the file system, that whatever you are storing, no matter if it is lesser than block, if it would be more than block, then one more block will be associated with that file. Let's say if it would have been 4097 bytes, okay, so one block will be completely filled and another one byte will be stored in the next block. And then these two blocks will be associated with the sample.txt. So basically, if your block is not completely filled, whatever is the remaining space of that block is going to be waste. Okay, it is not going to be used further for any other storage purpose. So that is the basic principle of the file system. Okay, and since it is a real file system, because FAT32 and TFS, these are the scheme, that is a real file system that is actually being through which you are actually formatting your hard disk. Okay, so so if it is FAT32, your complete hard disk space divided by 4 kilobyte, that many number of blocks you will be having in order to store whatever data you want. Okay, so each block is a 4096 bytes capacity. Okay, out of which, if you are using lesser number of bytes in that block, basically the remaining number of bytes are going to be waste. So it would be waste if you are storing numerous numbers of 1 byte file. Okay, so if I try to replicate it multiple times, so every file is only 1 byte, so it is going to just waste your file system. Why? Because there is no efficient use or optimized use of the available space in your file system. Okay, so even for the operating system or file system that you are using, very large number of smaller files are also should be avoided. Okay, so let's say the sample.txt is having only 1 byte. If I could create millions of such files, my hard disk space is completely filled up with very little information is in there, but still it will tell us that it is completely filled, though the actual size that got used is very very less. Okay, so for just storing 1 byte, we are still wasting 4095 byte for each block. Okay, now the thing is, if I create the copy of it, right, sample.txt, if I say control C control V, so I have created a copy of it. This copy will now be stored on the next block. So I will say the copy of, I will say copy of sample.txt will be stored in the next block. So this two, I mean, the another byte will not be stored on the first block. Why? Because once it is associated with one file, it cannot be used for any other file. Okay, the copy of sample.txt is different file, so it will be associated with block 2. You're getting me? So we are actually now storing the copy of sample. We have wasted 4095 plus 4095, or you can say 4095 into 2. So that many storage, or that much storage, or those many bytes we have just wasted. So that is the basic principle of any operating system, that once the block is associated with any file to store the data of it, basically whatever the remaining space of that block cannot be used for any other storage. Okay, and that's why the scheme, or that's why the data that you are actually getting copied should be very efficient, or not, you can say the data that you are actually copying into it should be in a very planned way, so that we can maximize the storage, or we can utilize the space optimizedly. You can say we can optimize the use of the space available. Okay, so this is the basic concept. Now what will happen is, when you go to this block, okay, it does contain some data, but block in itself is a dumb guy. Okay, it does not know for which it is holding the data. Okay, so if you go to this block, you will find some data, but that block will not tell you that of which file it is holding the data. Okay, so if you go to block 1 and try to see, and if you try to ask him that, hey block, which files data you are having, it does not tell you, cannot tell you. It will just hold the data. It knows the size, it knows its unique identifier, but it does not know that which files data it is having. Okay, so sample.txt and copy of sample.txt is like completely gone. I mean, there is a mapping that is now actually will be created whenever you store any data, and that is what is called inode map. It is again the second important concept. inode map. So it is a file. Okay, this is a file again that will actually keep the mapping between the file and its associated blocks. So what I will say is basically, let's say my sample.txt is the file name and its associated block is block1, blk1. Okay, now this will be written when we store the sample.txt on our hard disk. Okay, so this inode map will be updated with the mapping between the associated blocks and the file name. Okay, and this inode map is, now you can feel that it would be at most important on any file system, for any file system. So if you somehow corrupt this inode map, or if you delete the inode map, or if you just like, so it is whole and sole owner of this inode map would be administrator itself of Windows. Okay, and I never have seen that. I mean, I will try to check, but I know the concept behind it. So inode map basically will have the mapping between the file and its associated blocks. So it may be happen. It may happen that basically the sample.txt may be having more size, like 1 or 2 or like 8 kilobytes or 10 kilobytes. So it could be stored with block 1 plus block 2 plus block 3. So when you come to this inode map, you will easily come to know that the sample.txt is the data of sample.txt is stored on block 1, then block 2, and then block 3. Okay, if the sample.txt is big. Currently, since it is having only 1 byte and it is complete, it is not even completely occupy the block 1. It is stored on. It is just occupying only 1 byte from block 1. Okay, so remaining 4095 bytes are waste. Those are waste. Basically, cannot be used for storing other information. So sample.txt would be block 1, and I will say the copy of sample.txt would be block 2. Okay, so as of now, in above scenario, basically we have occupied 2 blocks, and we have stored a sample.txt in block 1 and copy of sample.txt in block 2, and remaining blocks are, let's say, empty. Okay, they can be further used to store the data from the other files. So whenever you store any file, basically ultimately inode map will be updated. Now if you delete this, if you delete the sample.txt, this entry will be deleted and your block 1 will be freed, so that it will be now used for store the data from the next file, any new file. Are you getting me? So if you do some updation, so basically let's say if you open the file, okay, in that block 2 and then try to insert more words into it, basically this block will be updated. Okay, so update, insert, delete, that kind of thing will be managed by this inode map. So that's why it is said to be a map, because it will keep the mapping between the file and its associated block. So at any time, inode map will give you the complete image of the file system, that will tell you that how many files are there in your hard disk and which files are stored in which blocks, basically. So when you try to open this sample.txt, it will be read from the block 1 and the data would be there. Okay, so while storing, while reading also, it will refer the inode map only. Okay, that will tell that from which block to read. Okay, because block itself does not have any information about the data of which file it is having. Okay, so block in itself is kind of a dumb box. So if you just delete inode map and you corrupt your whole file system, that's it. Okay, so if you really want to destroy anything, just rename the inode map file, corrupt it, go and enter something or delete it at all, and you will corrupt the whole file system. That's it, because the data is still there, but nobody now knows that which data would be pertaining to which file. Okay, this is the basic principle of any file system on this earth. Okay, so and Hadoop distributed file system is again no exception for this principle. Okay, so any questions as of now about file system? Okay, so one more rule that should be, I should tell, is that basically larger number of smaller files, larger number, okay, no, I'm repeating, larger number of smaller files are always bad to the operating system. And instead of that, a smaller number of larger files are always good to the file system. Okay, just try to, I will just try to repeat, just try to think. Larger number of smaller files, it means that if you are having very large number of 1 byte file, it is always be the problem for your file system. But a smaller number of larger file will be always good. Okay, because the number of inode map, because the thing is, for every file you need to create this mapping. If you are having larger number of smaller files, you will actually load your inode map. Okay, the big the inode map, the slowest will be the scanning about the file. It means that suppose if you are pouring very large number of smaller files in your file system, basically just to read one file at the last or somewhere in middle. Basically it needs to scan the inode map just to find the corresponding mapping of the blocks for that particular file. It will always be slow. Okay, so the reading of the very large files will be always slower. Okay, that's what I'm tracking in terms of inode map. So larger number of smaller files will be always good. Smaller number of larger a smaller number of larger files are always good. Larger number of smaller files will be bad for any file system. Okay, so this is just like kind of a rule out of it. Any questions of now? So that is the basic operating system, basic file system concept. Let me stop the recording.